Hello, and welcome to the Automated Trading with MATLAB webinar. My name is Stuart Cazzola, and I'm the Computational Finance Product Manager here at the MathWorks. The agenda for today's webinar, which is really outlined here on the slide, and I'm going to be going through this in detail, but basically there's three main components, and then there'll be an opportunity for question and answer at the end. So the first one is I'm going to give you a real quick introduction to kind of the use case we're going to go through, and then kind of show you the end system that we're going to build within the session of this webinar. So that'll be the trading system demonstration I'll be doing here shortly. Then the next stage is really we're going to talk about how do you develop and implement a strategy in MATLAB fairly quickly. In particular, we're going to be looking at first coming up with a successful trading rule and backtesting it. Then how quickly and easily is it to extend that trading rule set? And then of course, once I have a trading rule set that I want to use, I want to be able to automate the trading that's done through that trading rule set. So the second half, which is going to be new compared to what we've shown before. So if some of you guys have come to our webinars before, there's a webinar we've given recently called the Algorithmic Trading with MATLAB, which really focuses on the first half, developing an automated trading decision engine. So I'm going to spend less time in this webinar going over the topics there. I will highlight them quickly just so you know what the trading system is. But we're really going to be focusing a lot on the implementation of an automated trading system. There's going to be different components to this, but you'll be able to test through a paper trading. Well, really, it's going to be done through a simulator environment to see how well your trading system works. Then we'll look at the integration execution through a desktop trading system, because many of you may be wanting to work through your current broker who may have a desktop API that you'd like to be working through. So you'll be running MATLAB alongside the desktop application. And then, of course, the final piece will also be talking about execution through a server-based system. We'll be really looking at a fixed-based protocol system here for that. So this is so that you can actually, interface MATLAB with some other order management or order execution system on the back end that's using fix. And we'll go through that and show you how you can do all of this within MATLAB and then conclude with the wrap-up and a question and answer period. So with that, let me start by kind of setting the stage for what we'll be looking at in MATLAB in terms of the use case we'll be using. And really what we're going to be doing here is assuming that you're a commodities analyst is really the field we're looking at. So we're going to be looking at oil futures. So what we're really going to be doing is looking at how do you develop a strategy quickly in MATLAB. As I mentioned earlier, I'm not going to show you every dirty detail, but I'm going to show you a quick introduction to developing a strategy in MATLAB. And then I'll show you the trading decision engine, which kind of allows you to input multiple different trading rules into it, and it'll select the best trading strategy from that based upon a back test. But management also requires that you can prove that it's been tested on historical data. They don't want to run something that hasn't been proven or paper tested for a while. And then, of course, they want to use whatever sophisticated techniques you can bring to it. And in particular, what you really like to do is have a general frameworks where I can give you different signals from the market. I can use this system that we're developing called the trade decision rule to select the best trading strategies from a variety of different inputs. And then, of course, this needs to integrate within existing data and execution systems. So with that, let me really get started by showing you kind of the end demo, kind of the everything we're going to build up within the context of this webinar that we have today. So we're going to be basically looking at the three components here within the demo, which is we're going to bring in the live data. We'll be running it through a decision engine, which is something that we'll be developing in part one of the webinar. And then we'll also look at the different execution systems. So with that, let me go ahead and transition to MATLAB, and we'll go ahead and get started. Okay, so what we're going to do is we're going to actually start up the trading system, and I'm going to walk you through the components rather quickly. So for those of you that might be new to MATLAB, I will be giving more of an introduction to MATLAB when we develop our first trading strategy. We'll actually walk through developing that, and I'll give you an overview of the MATLAB desktop then. But at this point, what we're just going to do is run the trading strategy. So let me first go in here. I'm going to open up the function and run it, which is going to actually start setting up our trading strategy system. I'm going to undock that component. I have basically this component, the tick history replay engine, which is this component, and then I have the server, the fix server here. So let me walk through real quickly what we have, and we also have kind of an order entry system here. So let's start with the order entry system. So this is an application that's off the MATLAB thread. So I can actually enter in, like let's say a quote to buy TMW at market prices using fix 4.2. We'll go submit. And what happens, it submits the order. There's an execution sent to the server that's shown here that gets back the result and says we bought 100 at a price of 12.3. So the fix execution engine here will fill every order, and it always fills them at 12.3. So it's really just a system that we can use to test that our fixed messaging and server setup is working correctly. So we'll be using this here in a minute. Basically what is here, so this is the tick history feed. or what you can think of, this is the streaming amount of data that's coming in. And what we're using is the Reuters playback engine. So this is a server that is set up to send trading signals, or to send market information out to something that is listening. In this case, it happens to be MATLAB. And you can see MATLAB here. Now you can see that the execution time is actually, 6/100ths of a second. So that's what it takes to basically run the execution, send all the orders, and come back between calls. What's coming out here is you can see the actual trading message being sent out by the tick history system. It's run through a trading strategy function in MATLAB that we'll be talking about later. But you can see the tick-tock of that function being timed here. You can see a plot output of what's going on at the current moment. So this is the price history given at the current simulation speed. And this is the order signal. So 1 being a buy, 0 being a sell. So right now we're just looking at a buy-sell strategy, and right now it's just sending out the orders. So what we have here is an Excel application that's listening to everything that's being sent out of MATLAB off of a messaging queue. So we're capturing all the buy-sell orders that are coming off that messaging bus or the messaging queue in the Excel spreadsheet, and you can see them being updated here. Now the next thing is we can go in and look at the market execution system that is based upon the fixed protocol. You can see that I'm getting buy-sell signals that have been coming in from the strategy, and then as well you can see the execution of them, of course all at the same price. Now the last thing I'd like to show that we actually are using XTrader to receive orders. So the orders are being sent back out to XTrader as well. What we have going on here, let me just kind of resize these windows so that you can see this, is that we have our order log here in XTrader, orders and fills. So this was something I was playing around with earlier this morning. But you can see what we have now is I'm sending in just a limit order to XTrader, and it's basically at 120 or 110. You can see it's working because none of these orders are actually being filled at the moment. I set them outside the bounds of the current simulation parameters for the eBrent parameter that's in the TT simulator. So it's running about 113, 114 prices at the moment, so these will not be filled, but we'll talk about this more later and show you that. But right now you can see that it is updating with new working orders. They're updating every time the signal changes. We can even go over here and show the plot, and you can see when there's a new signal generated, you should see a new change. So it's going back and forth. So let me go ahead and stop this system, which is going in here into the tick system replay. I'm going to go ahead and cancel all, because what we're going to do is we're going to actually come and rebuild this throughout the course of this webinar with a variety of different components, and we'll come back and see how this works later. Okay, so you just saw a demonstration of the system running. It's basically a system that's implemented and runs from within MATLAB, but integrates to a variety of different components. So a little bit later on in the presentation, I'll be talking about how you can actually deploy tools using our MATLAB compiler and deployment products to put MATLAB technologies within a variety of different systems if you don't want MATLAB to be the front end of your system. So with that, what we're going to do is we're going to start out by going back to developing a trading strategy initially in MATLAB. So this is more about the research and development phase of your workflow. A variety of considerations you have are bringing in historical data from a variety of sources, developing your strategy or model, calibrating it, and of course backtesting it and making sure that you have a viable trading strategy. And we're going to use a trading strategy modeling to develop basically a decision engine that we can put in almost any different technical indicators, calibrate, and deploy to an automated trading system. And that's really what we're going to be talking about with the decision engine, is kind of the heart of the trading system, and then how it hooks into live feeds, or how you can send out trading systems to other execution venues. So with that, let's go ahead and get started with the strategy development, or basically building our trading engine itself. So some of the requirements that we had, if you remember from the earlier slide, is also reflected here, is that it needs to have sophisticated analytics. So in this case, we're going to use more than just one rule, so we're not going to use a simple moving average as an example. What we want to do is we want to develop a framework that you can add a variety of different indicators. They could be statistical, they could be technical averages, they could be almost anything, even news feeds or any kind of signal you can generate and send into this using a 0 or 1 as kind of the buy or sell signal. You can use them as essentially market states, and this trading system will choose from the different incoming signals which ones are valid in a variety of different combinations with others, and it's going to develop a trading strategy based upon all those indicators. And we're going to be using a genetic algorithm approach, or genetic programming, to actually do that decision selection for us, and I'll be talking about that a little bit later. The other thing is that we want to have a scalable environment, so we want to be able to look at things from kind of trading on a daily, monthly average, if you will, daily, weekly, or monthly average, to something that could be even intraday. And we'll be talking high frequency in the context of this webinar of anything that, that is an intraday frequency. So daily or less is what we'll really be talking about here. And then, of course, we wanted the ability to add different trading rules and backtest quickly. And then that leads to the quickly being able to develop and deploy these things. We want a framework for taking a variety of different trading strategies and put them back into our automated trading system as quickly as possible. So with that, let's begin with the first task, which is developing a backtesting environment. And you will be using that around an example trading strategy. So with that, let me go ahead and transition back to MATLAB. Okay, so what we're looking at here is the MATLAB desktop. So for those of you that are new to MATLAB, I'll be giving you a brief overview of the desktop environment and how you can work with it to develop a variety of different algorithms or applications in MATLAB. So what we're going to start with first is we're going to pull some data in. And one of the things in MATLAB is that it operates out of what is called the current working folder. So if I have a lot of files that are stored that are specific to the project I'm working with, in this case it's the webinar automated trading, I can change the path to that folder, and you can see a listing here. I'm in the current folder listing. So this is all the files and applications and data files that are available to my application. Now, for example, these three folders are highlighted in a clear color, and then this one's shaded out. So what this means is this folder is not actually on the current path. So if I wanted to add all these folders so I can work with them, I can go add to path, select folders and subfolders. So all these folders are now available to work with, even though they're a subset or they're under a directory below the automated trading folder. So for example, my data Brent1D is here. Let me go ahead and open this up outside of MATLAB, basically opening it up in Excel to give you a view of what's inside the data. So you can see I have date, volume, open, close, high and low, starting from 2003 all the way to 2011. And it's essentially daily data with the exception of non-trading days, not included within the data. So that's the structure of the data. We're going to develop a trading strategy on this. Just if it wasn't clear, that's essentially the Brent oil prices, daily oil prices. And we're going to develop a trading strategy based upon that information. Now, one of the quickest ways to bring data into MATLAB is to just quickly double-click on the data source, and that brings up what is called the import wizard. Now, the import wizard will recognize a variety of different data types and do some conversions for them if they're a recognized format. So, for example, the Excel spreadsheet had a date string, or basically a date number, representation in Excel. And you can see the green is taking anything highlighted in green here, is taking them Excel dates, and it's going to convert them to a date number format in MATLAB. So it's changing the native date type of Excel to the native date type of MATLAB. And we'll talk a little bit about that later and what that means. Everything else is going to bring in all this blue, and anything that's non-numeric is going to replace it with a zero value. So this is one way you can handle missing data. In this case, we're going to leave the default. And I'm going to go ahead and import. It's going to bring this data in as a matrix. I can bring it in as column vectors or even a cell array. So I'll talk about the different data types once I get back to MATLAB. So it spins, and it imported that into untitled. So untitled is basically a data type, and it showed what's within the workspace. So what that means is this is the data that I have in memory currently that I can work with in MATLAB. So for example, let's go ahead and change the name to data. And let's say I want to look at it. So I can just type data in the command window, and it displays everything in basically a column format. If I wanted to pull something out, I could do operations on that. But I can also double click and query into the data. I can see that the date number's here, the volume, and then the close value here. Let's say I wanted to price or to plot. So you can see I have a variety of things to work with. So let's say, for example, I just want to plot the data. I can select the close price. You can see in the plot picker here, there are a variety of different plot types I can look at. I can create a simple 2D line graph using linear axes. So we'll go ahead and select that one. And you can see it created a plot of the closing price based upon the index of what's in essentially the array or the matrix. So it's plotting column 3 over time. Now some other things I can do, for example, is let's say I wanted to plot the high, low, open, and close prices. And you can see them plotted here. Quickly zoom in, and you can kind of see how they change with respect to each other. So that real quickly gives you an overview of how you can do exploration and quick plotting in MATLAB. One of the nice things is that you also look, the commands that I execute within the interface are executed to the command window. So if I wanted to redo that work, I could just hit up arrow, and I could capture the work I just did. Or I can also save these commands for later use if I want to, and I'll talk about that in a little bit. So let's go ahead and start by developing a simple leading lag moving average indicator. So what I want to do is I want to actually extract just the close price, and I'm going to call it LCO close for light crude oil close. And I'm going to pull out just the information in column 3 of the data variable. You can see it creates a new variable called LCO close, and what I now have is a vector that I can work with. So now I've pulled that data out. The next thing I want to do is run a moving average on that, and it's going to generate a leading and a lagging moving average. So there's a moving average command in the financial toolbox that allows you to take an input, run a 5-day and a 20-day exponentially weighted moving average. I go ahead and enter. You can see the results of the different two, or I can look here and see the variables in the command window. So now I have a leading and lagging indicator. One of the things I might want to do is actually plot it. So I'm going to use an indicator chart where I'm putting in basically the close value, the lead and the lag indicator, and once I hit enter, you can see I now have a labeled plot. This is a serial day. Shows me the close price, the leading indicator, and the lagging indicator. Now if we go ahead and look closely, what you can see is the leading indicator is a fast response moving average, so this is the 5-day moving average. The lag is the 20-day moving average, exponentially weighted, of course. And you can see that these two moving indicators plotted on the data. So for example, if I wanted to develop a trading strategy, let's just zoom in here real quick. You can see where they cross. Maybe when one's over the other, it's a buy indication. So for example, when the leading indicator is above the lagging indicator, it's a buy indication. When it's below, it would be a sell indication. So we're going to develop a simple trading strategy based upon that line of thinking. So let me go ahead and capture how you can do that quickly in MATLAB. So we're going to create a new variable called signal. We're going to initially load it up with a bunch of zeros. So we're going to use the 0 command, which is going to create an array the size of the LCO close. So we should have a vector called signal that's the same size as LCO close. And this is right now, all this contains is a bunch of 0 variables. So one of the first things I said was when the leading indicator was above the lag, we'd like to generate a buy sell or a buy signal. So in this case, we're going to go when leading is greater than lag, we're going to give it a signal indication of 1. So this is our buy signal. And then of course we can do the same thing. So it's less than 1. So now we have a signal. And what we're doing here, if you actually notice, is we're running what's called the logical operation. So whenever the lead signal was greater than lag, anything in signal should be replaced with a -1 and vice versa. So if I go in here and look at signal real quick, you can see I have zeros where it was neither condition greater than, it was actually equal to 0. Or I have a -1 and a 1. So you can see now I have a bunch of signals that I can use to actually develop a trading strategy. So let's go ahead and do a simple quick calculation where my returns are calculated essentially as, we're essentially creating a 0, adding in the signals from size 1 to end, and then we're multiplying that by the LCO close. So this is going to give me my return information. So I'm basically multiplying the change in the signal by the difference in price, which gives me my return vector. And then we'll also do a profit and loss calculation, which is we're just going to sum up all the returns. And then for scaling, or basically a performance metric, we're going to use a Sharpe ratio. So first thing I need to do is I want to annualize the daily performance indication that we're going to have here to that of the Sharpe ratio on an annual metric. So the annual scaling is the square root of 250, and where 250 is the number of trading days in a year. And then, of course, we're going to calculate the Sharpe ratio as the annual scaling times the Sharpe ratio with the returns. And the 0 here actually indicates that we're not accounting for the risk-free rate. So we're not adjusting our returns for the risk-free rate in this case. And you can see that I have a Sharpe ratio of 0.77. So if we go ahead and plot this on a rule chart, it's using the moving average indicators. I'm sending in the price history with the close, the lead, the lag, the signal, the profit and loss indicator, and then the Sharpe ratio. And this all gets populated on a plot where I can quickly look at things and see how well the trading strategy does. So for that very simple lead lag moving indication average, you can see how well this performs. As a Sharpe ratio of 0.77, which is not necessarily that great, but you can see that there's a lot of trading fluctuation going around here that's really not doing anything for quite some time before we actually start to develop a decent winning strategy. So the nice thing about MATLAB is everything I've performed interactively at the command window, I can actually capture and reuse for later use. So if we go back and look at some of the things I did, here's the session for everything I did this morning. We can capture some of these things. Let's say I want to capture the generation of lead lag, the interaction chart, and then the generation of the signals. I can do a right click and do create script. Or these are a listing of commands that you can execute in MATLAB. And I can actually control how these things get executed in MATLAB in a variety of different ways. So let's go ahead and say load. I can add comments, load data, calculate trading signal, and so on. What you see here is now I have a script that I can actually reuse. So if I go ahead and execute this script, so it's going to take this cell, highlighted by the double % sign, and then I can hit advanced cell and execute. So it executes that cell, plots it again, you can say reproduce my work, and the same thing here. So this is really a script in MATLAB. What that is just a collection of commands organized in a way that makes makes logical sense to be able to interactively work with that. So I've already prepared a script earlier that actually adds more comments to the one we did, and this is called Demo 1 Intro in MATLAB. So if I go ahead and open this one, what you can see is I have a strategy here, or basically the same file that I just showed at the command window with a few more comments. So you can see I have basically a double % sign. This is the cell section, and then I have some comments here that describe more information about that. Now the nice thing about MATLAB is once you develop a script, you can add comments to it as you're working, and then you can go ahead and push this button here called Publish Demo 1. So let me go ahead and clean everything up. You can see this time rather than using the import wizard, I'm using the XLS read command directly and performing the same calculation. So let me go ahead and publish this. And what this is doing is going back through those set of commands and executing them and creating any plots or data outputs that are being captured, and they're actually going to be generated into an HTML report. And what you can see here is the rendering of the web report where each of the cells, for example, each of the cells represent the section of my report. And the top one here, since there's no commands underneath it, is actually the header. It lists every command so you can quickly look at them or move forward to them in hypertext notation. And then of course you can scroll through and see the entire report that reproduced the work we did at the command line. So this is a nice thing about MATLAB, is it allows you to quickly automate and capture ideas and reuse them in a variety of different ways. So one of the things that I showed earlier was I used this indicator chart moving average. So this is actually a customized chart type that I created earlier, which is actually a function. So recall when I was interactively working at the command window, I did some plotting, some simple plotting. And essentially what this is doing is creating that plot using a variety of different commands. But this time, if you notice, it's being called with function syntax. So the nice thing about MATLAB is that if you repeatedly do something that's basically the same, you can encapsulate that in what's called a function. And the function allows you to pass in an input, has its own workspace internally, so everything in here has its own workspace that's being generated, and then only the outputs will be passed. In this case, there are no outputs being passed. It's only going to create a chart. So that's the indicator chart. So if I go ahead and rerun this, you can see it creates this chart here. So there are a variety of different components that I'll be using here. If you want a detailed explanation of how these work, I recommend looking at the algorithmic trading webinar that's on our website, where we walk through a lot of the components of doing this in more detail. But essentially, this was the end of Demo 1, which was simply to create a simple trading strategy. Okay, that basically summarizes the first part, which is kind of creating your own trading strategy within MATLAB. Now, the rest of these demos that I'm not really going to get into in detail because they're described in the webinar Algorithmic Trading with MATLAB, I'm just essentially going to go through them and show you some of the published results really quickly. Now, the last one I want to talk about really quickly is kind of the whole part of the decision engine. That's actually run in Demo 4, rule selection. So I'm just going to go ahead and publish this one really quickly so we can look at that. So I'd like to spend more time on how do you integrate with live data feeds, as well as potentially fix engines. Now just to get started, so the first part loads in the data again, as we did previously. It goes through the calibration of a new technical indicator called the Williams %R. So what we want to do in this example is we're going to use the Williams %R indicator, and then we're also going to use an RSI indicator. So we're going to use 3 indicators, so we're trying to create. So this is running through a genetic out and back test. But what we're doing is we're running 3 indicators. And what we want to do is take these indicators, combine them in different combinations using logics. So I could take signal 1 and signal 2. I can take signal 1 or signal 2. I can take signal 1 and signal 2 or signal 1 to generate my trading strategy. And essentially what that's doing is I'm generating those 3, putting them into a matrix where each of the columns is the different signal, and there's a label. And then what we have here is essentially the different states of those trading strategies, where red is a sell and green is a buy signal. And you can see for the Williams percent RSI and moving average over this set of data, this is what each one of those technical indicators would give us. Now the point here isn't that you necessarily have to use technical indicators to use this strategy I'm going to talk about in a second for choosing the best strategy out of this. But you can use anything that can be described as a state. So it could be news, it could be analyst opinion, it could be, fundamental data. It doesn't really matter as long as you convert that into a signal that says buy or sell. So what we have here is 3 different signals, and what we want to do is take the combination. So going back to the combinations, I'd like to take signal 1 and signal 2, or signal 2 and signal 3, or maybe a combination of signal 1 and signal 2 or signal 3, and combine them in different ways to find the best strategy. So basically I'm taking different trading components or different trading signals, combining them together using logic to come up with a trading rule. And what this has done is it's encapsulated in essentially a bit string format. So what I have is the first signal, so this is the first moving average. So this denotes a 0 or a 1. So what this means through here is that signal is either on or off. The next 2 are basically a binary representation of the logic that we'll be using. A 0, 0 would be an AND, a 0, 1 would be an OR, and a 1, 0 would be an exclusive OR. 4 is whether or not you're using the next one would be the RSI indicator. And if it's green, that means you're using the signal as is. So if the signal says buy, then you would buy. If it's red, it means you're doing the opposite strategy. So if the signal comes out and says buy, you don't want to actually sell. And then the 5 and 6-bit position, these are, again, a binary representation of the logic gates AND or exclusive OR. 7 is the Williams percent indicator. So again, green is you follow a strategy directly, red is you do the opposite of it. Then these last 3 bits here are telling us which signals to use. So for example, this one here happens to be red, which means it's off. So the Williams percent R signal right here would not be used. You'd only be using the moving average and the logic gate combined with the last one. So again, if you're really interested in understanding how the genetic algorithm works using the genetic programming technique, it's discussed in a lot more detail in the algorithmic trading with MATLAB webinar. The end result is that we end up using the genetic algorithm to run through this back test. Here's the final result. We put in an initial population that's pretty much random. After it ran for a while, it started to converge on what is more of a uniform population. You can see that we found what's probably a good solution. It may not necessarily be global because it's not guaranteed by a genetic algorithm, but it's highly likely that you found a good solution within kind of the search space we defined. The best strategy or the best rule that came out of this was you take signal 1, which is the moving average. A 0, 1 indicates that this would be an AND operation. So you take signal 1, the moving average, ANDed with the RSI. 0, 0, 1 would be OR. So it's moving average or RSI, ANDed together with the opposite of the Williams percent R. The last 3 bits tell me that this is only using the moving average and Williams percent R. So what you do is only take the first part of this. So this would be the moving average signal as is, ORed with the RSI. So that would be the final trading strategy. And this is the actual trading strategy that we end up implementing in the trading model that I showed you earlier, and we'll also come back to in a minute. Then here's the final results of using that strategy. We can see that we've got the best Sharpe ratio we've seen so far, which is about a 2. Okay, so that basically concludes that part. Now the next thing I'd like to do, go ahead and clean up. So the next thing I'd like to do is actually open up an example of how you can pull prices from XTrader, so you can get live price information directly into MATLAB. So what this is going to do is it creates an object called X. It's a class XTrader, so it's an XTrader interface. Now XTrader is not currently up and running on my machine, so what it does is it actually invokes the login and wants you to log in using your credentials. So it's going to load up XTrader, and you can see I have XTrader loaded here. So one of the things I want to do is actually go ahead and get some price information. So let me go ahead and go to XTrader real quick and show you where you can find that. So what we're going to do is we're going to pull information off of a simulated gateway called TTSimF, or actually TTSimG. We're going to pull the Brent crude futures prices from this instrument here called the October 12th Brent crude. So if I go ahead and I'm going to go ahead and open up it in MD Trader. So what we have here is a market depth chart, and what we're showing is the prices, and then the bid and the ask quote size, and then the last trade. So what we want to actually do is we want to pull the current price and attach an event for any time there's a trade. So let me go ahead and close this for now and go ahead and create the ability to trade directly from within MATLAB. So the first thing is once you have the XTrader object, that allows you to attach notifiers. So this is anytime there's an event that happens, we're going to create a default notifier. We want to attach the instrument. So what we want to do is we're going to go through the exchange, the TTSIM-G gateway. The product we want is IP Brent. The product type happens to be a future contract. It happens to be a future, and the contract is the October 12. And we're just going to go ahead and give it a name called Demo 5 Price Update. So we'll go ahead and create the instrument. The next thing is once the instrument is created, you can then attach the instrument to the notifier. So now that I have an instrument, I can attach it to a notifier, and I can get event callbacks from that. And here's some examples. So for those of you that are interested in this, this is an example taken directly out of our product documentation, and all these are developable in the data feed toolbox. And one of the things is now that I have a notifier, I can actually register an event. So anytime that an event occurs, I can have different kinds of callbacks operated. So what we have here is one that's going to be triggered anytime anytime you start it up on notify found, if it's not found, or if there's an update to the notification. It's going to run the TT instrument found, TT instrument not found. So if it can't find the instrument, you'll get this one. If it finds it, it's just going to say that it found it. And then the instrument update, which is actually a callback function, which I'm going to open real quick. And what you can see is that this is just going to display essentially the last trading price from MATLAB. So this is an example of creating a callback that's attached to an event notifier. And anytime that event gets triggered, it's going to signal MATLAB to display the price given this information. So let's go ahead. So we're going to go ahead and execute this cell. The next one is that you need to update the filter, so you can update it to what types of information you want it to return. In this case, we're going to only look at the last price, the last quantity, and any changes to those. And then the last one is we're going to actually start the listener, so we're going to do that by issuing this command, which is going to open it. And it's going to open it because you can actually attach multiple listeners and multiple instruments. So we're just using the first one, and we're going to go ahead and do that. And what you can see is that it found the instrument, so you got your found notifier. It's displaying it here. You can see that an event was called here, that the last quantity traded was 1. Now, as you can see, this is not moving very fast. So what I'm going to go ahead and do is I'm going to go ahead and go back to XTrader. I'm going to go ahead and, let me go ahead and open this in the market grid. Is create an order for 5, and we're going to do that at the market. We're not going to create a dim we're going to do it at market, and we're going to do it create buy. And what you can see is that the last trade was 3. And if we go back and look at the order fills window, what you can see, so this is one that I did earlier today, what you can see is that it filled 5. The last few orders were 2, 1, 1, 1, and then the last, I think, market 1. If you look at back through the event return to MATLAB, so you can see it actually updated with all of the information of the last trades. So this is an example of how you can actually listen to notifiers that occur in that environment. And this will continue to update as the market information arrives or things change. So that's one way of working within MATLAB, is we're going to actually show kind of an order submission. So what we're going to do is actually, how do you send orders from MATLAB? So here's an example. Again, we create an XTrader object. I'm going to go ahead and clean up my workspace. So we're going to create an XTrader object, the instrument, same thing. Now we register an event on change update. We want the order service status to be called. So this is going to tell us on exchange status update what's going on with the order. You create the order set, and here's the commands to do that. So you want to enable order rejection data, update data, and then you want to also have a callback for order notify normal mode. So we're setting the normal notify mode. The next thing too is we're going to set the limits. Some add callbacks for when the order is filled, rejected, or submitted, or deleted. What is it going to do? It's going to, in this case, it's going to display different things to the command window. These are all standard within the data feed toolbox. You enable send orders, so this is actually kind of a prevention. So once you open it, now you can send orders to Xtrader. Before you do that, you want to create an order profile, which is essentially what is it you want to trade. We're going to attach the instrument to that. The default customer profile, so if you have a profile in Xtrader, you want to attach to that. And then we're going to set the order profile to buy sell. In this case, we're going to buy an order of 100. Here's the command if you want to do that at a market, but what we're going to do is we're going to actually submit a limit order, and let's go ahead and change this to, let's say, 120 today. And then this script, which is also from the data feed toolbox, has a variety of other examples for setting different order types, like such as a stop order. And then the last step is going to go through a loop that's just going to check, make sure that the order server is up. If it's not, then it'll issue a warning. And then we're going to submit the order. So once we verify that it's up, we're going to submit the quantity defined in the order profile, and then we're going to display how many were sent. And then if the server is not up, it's going to say that the server is down, we were unable to submit an order, so it's going to give us the notification. So I'll go ahead and execute this entire script, and I'll go ahead and load up Xtrader again. This time the order fills, and you can see that we now have, if I remove the two that we did earlier from the window, you can now see that we just submitted an order at a limit price of 120, filled at 113, and it was filled. So you can see that in this case we actually were filled in this order, and you can see the current state of our profit and loss positions. I can go ahead and turn them all on for all my trading activity today. You can see that actually, because of the one that I did earlier, we're down and we hold a net position of 205. So that's an example of how you can use the order submit to submit an order. Now I can also actually delete an order if it wasn't filled. In our case, it was actually filled, so this will not really do anything. So that's just a quick example of how to set things up and run them. In the interest of time, because I want to talk more about how you interface to the variety of other components, such as the fix engine, the messaging bus, I'm going to actually move into the next demo, which is demo 6. So let me go ahead and clean up my workspace. And demo 6. So one of the nice things about MATLAB is you can actually work with Java components or even .NET components directly from within the MATLAB command workspace as if they were MATLAB commands. And this next set of files is actually kind of structured to give you that feel. One thing I do want to go to is I want to show you quick fix. So I'm going to be using some libraries and importing them into MATLAB, or as jar files or Java archive files. And they're located here in C Sandbox Java Quick Fix. These are the variety of files that we're going to be using, as well as some of the optional library files here for some of the different data logging. So what I'm actually going to do is I'm just going to use the QuickFixJ files as is. I'm not actually building any other Java components. I'm going to just pull them into MATLAB, build a simple trading application based upon what they have in their examples file, and then run with that. So just give you a feel. So these are jar files, but if you notice I can expand them in MATLAB and take a look at a variety of information that's contained within them. So I can actually export Java components in MATLAB. There's 3 different applications that are contained within this examples that are shipped with the QuickFixJ download. There's an order matching, which we're not going to be touching at all today. There's an executor, which this is a simple market matching engine I showed you earlier. All it does is order all or fill all orders at a constant price of 12.5. I'm going to run this, but I'm not going to actually do anything with the code base there. And then there's the Bonsai application, which was the order entry application that they have. And what I'm going to actually be doing is using some of the components in here. Now, one of the things is here you can see I can browse a variety of different objects and classes, see the different classes that are available to me. It looks like there's also a UI component, so if I wanted to look at the UI components, I can use them. So this is one way I can quickly browse a variety of different components. In order to use these jar files, what you want to do is actually have them on the Java class path in MATLAB. There are 2 ways to do that. You can put them in the class path text file. So if I go ahead and just type that out to the command window, this is the text, the Java class path.txt file. It's located in the MATLAB root directory. You can see all the different Java files that MATLAB has defined, and then I've added them here at the bottom. And what this does is actually allows you to add Java components so that you can work with them directly in MATLAB as if they're a MATLAB function or even a MATLAB object. This puts it on the Java static path. The other way to do that is to use a Java add path to put it on the dynamic path. But in most cases, it's best to put it on a static path if you're going to be using a lot of components. So just to verify that they're on the class path, I'll run the Java class path command. You can see displayed to the window is all of the class paths that are available for me to work with. The ones that I'm most interested in are the quick fix ones, so they're there, and currently I don't have anything in the dynamic Java path. So one thing we're going to do is we're going to actually work with a variety of different packages from the quick fix. So we're going to use the standard quick fix ones that has all the capabilities for the core messaging. We're going to use the Bonsai application and some of the Bonsai UI components. So we're going to go ahead and import those into MATLAB. The other way you could also use these in for example, session settings is coming from the quick fix library. You can do quickfix.session settings and call it explicitly. Just to make the code easier to read, I'm going to import them here so that I can just type their commands and execute them later. So we'll go ahead and import them. Now the next thing is if you look at simple application. So if we go back to the Java and just do a simple index. So this is the help that comes with the quick fix application. If you create your first application, it goes through, the really thing is you want to overload the application interface. This contains all your logic. And there's methods. The one that you really care about is from app. This is the one that's returning messages from when you send it to it. And here's a real quick example of creating your first app. What you really need to have as part of that is you need an application. So this is something that you have to specifically define. The session settings, message store factory, a log factory, a message factory, and then acceptor or an initiator. In our case, we'll be using an initiator. Then you can start and stop it. So that's the components of a Java application. Now I can reproduce the whole thing in MATLAB really quickly using essentially kind of the same type of syntax. So I'm creating a sessions object. So let's go ahead and execute this one at the MATLAB command real quick. And I'm sending it in the Bonsai config file. Now what's in the Bonsai config file? Well, now I actually need to probably be back in my automated trading. But if we look at the Bonsai config file, it's simply a configuration file that tells the fix interface that's in QuickFix.js what types of things to use. So it's telling it, what's the protocol on the port for Fix 4.0, Fix 4.1. I can have multiple different fix sessions that have different protocols used on them. Some heartbeat parameters, start time, head time, some file storage. So this is a configuration file that's needed. It basically sets up the profiles that you're going to use. So this allows you to dynamically at runtime change the protocol you're using or change a variety of the parameters of the quick fix environment. And I'm not really going to go into detail there other than I'm using the default application. If you really want to learn how to use this, I would suggest looking at their documentation. But I should mention that QuickFix is from quickfix.org, where you can find the QuickFix.js implementation. So it's a native Java-based implementation. The reason I'm using it is because you can use the C version, but it's much harder to handle callback events in MATLAB. A .NET or Java version is much easier to use in MATLAB to issue callbacks. So we're going to basically start out by creating the settings. So this is just going to create a settings object. And you can see I have a store factory object now in MATLAB. And if we do get on that object, now you can see something more interesting. So what this is telling me is the class type, but it's also attaching other events that could be handled to this. So there are no notifications that are available currently because it doesn't tell me a callback method that we can use, but you can see I can get more information. So let's go ahead and execute all of these. Okay, now we can see that all of the objects have been created in the MATLAB workspace. You can see them up here. One thing I want to do is take a look at the order table because it's actually interesting. This is essentially the table model of the GUI interface that I'll be showing you in a minute. But you can issue a callback onto that, so when it's changed, MATLAB can actually listen to that. So if I do order table .get, I can get the parameters and events that are available to me. Now this is the one that's interesting because now you can see that it has three actual listeners, or one actual listener. So what this has is one listener, table model listener, which says when the table is changed, callback. So I can assign a MATLAB function here that says when the table is changed, do something, and you can also have optional data. So this is one of the things that MATLAB knows about the structure of the class and whether or not it has any event listeners. So you can actually attach event listeners to them. So in this case, I could add one whenever the table changes, tell MATLAB. So this is an example of how you can add listeners to Java objects. I'll be showing a little bit more about that later, but let's first go ahead and create the frame, which is essentially the structure of our application initiator. What you can see is there are a variety of methods here. You can get class, you can set a variety of parameters, and you can start and stop it. So we'll be using a start and stop method. So when I run the start method, it's going to start connection to a fixed execution gateway that I defined in the configuration parameters, listening on a port, and then I can also stop it from communicating with a fixed exchange server somewhere out there in cyberspace, if you will. So before I do that, before I can connect to anything, I first need to start that. So we're going to go ahead and start that component that's shipped with the QuickFixJ, which is the executor application. So we're going to run that in Windows real quick, and you can see that it started. And what I have here is this listening for connections here. It's going to issue commands to this command window based upon the server connection it's servicing at the time. So right now there's nothing listening to this because it's currently waiting for a connection. So what we want to do now is, let me go ahead and minimize this, and hopefully we can. Alright, so let me go ahead and rearrange some of these windows. You can see right now we're listening for a connection within the executor application. You can see I have an application here that's not allowing me to submit any orders. This is my order execution console, or the Bonsai app from the QuickFixJ set of files. So the way to get the executor system engaged with the execution or the order entry system, you need to actually start the communication between the two. So this code is going to do that. We'll go ahead and start. What we'll see is now that I have an available protocol, I can actually play around with different protocols and send orders. So for an example, let's go trade a symbol TMW. We're going to go ahead and say we want 4. Submit. You can see that it was entered into the order table, and then the execution table gives a summary of what came back. So the fixed message protocol says that there was a message, we filled it at a price of 12.3. Now we can also go ahead and look at different protocols. We can do like 41 for 4.1, submit. Take a look at the execution. Let's do 4.4. And then we can also do a change. And then we can also change the actual from buy to sell. And you can see sell. We can see where we stand in terms of the orders. You can do short sell or a variety of other things. We can also even send limit data. Unfortunately, limit data are not. Or we'll have to set this up to 15. It's going to fill it, of course. So it already says to fill it at 15, even though we set it in a limit order. You can change the side, but you can also see that it'll fill everything that it can. But in that case, it didn't fill the sell side for 50. Let's try it again just to make sure and verify. It wasn't filled. So depending upon how you submit the orders, the execution system will always fill everything. But if you submit a limit order that can be filled, of course, it will not fill it. So that's the definition of the system here. It actually comes. This system actually comes with the QuickFixJ installation. I've just used the components to connect them into MATLAB directly. Now let me just show you how I'm going to use this system to actually send orders from MATLAB to the system without having to do point and click. So I'm going to automate it. First thing we're going to do is we're going to pull back an order table. So this is how you do that in MATLAB. So it's going to pull the 0 order. So it's going to pull the very first order that was entered. We can go ahead and look at that. So you can view the parameters of the order. And you can see that it is MW, quantity 4. It tells you all the different parameters that were there. You can see some heartbeats. They're still being sent back to the MATLAB because we're still connected. So that's one way of looking at it. So you can pull all the information here. So we created a default. So we're going to pull an order, and then we're just going to update that with a different value. So we can use the order table object to add the order. So what we're going to do is just submit this order again. So we're going to resubmit this order. What you're going to see is you're going to see it show up here, and then it's going to show up here. But this time we'll go ahead and change it to a 4.1 protocol. So what we're going to do is submit that using the add order method of order table, and then application send actually tells it to send it to the execution system. So we execute that, and what you see is a new one entered. This time you can see the change in our open positions, and then you can see that it was filled. So you can see the new order was sent. It's still listed as part of the same open order, and then the execution. Now what if you wanted to change that order? So we showed you how to grab an order, use that order object, and then resubmit it. So in this case, what we want to do is we're going to pull back the session. So we want to use the same fixed session when we create a new order, because that's not something that's defined by default. So we'll go ahead and create a new order, and then look at the methods. So you can see here's all the methods that I have available to me. There's a lot of get open, get original ID, get quantity, get session ID, get side, get stop, get symbol, and a variety of other set ones. So what we want to do is we're going to actually pull back from the initiator, the session. So we need to get the session that we're connected to here. The next one is going to set that session ID to the parameter that comes back. We're going to set a new symbol to MW, so we're not going to trade any of the TMWs. We're going to start trading a new one. The initial order quantity of 50. We're going to set the initial open quantity to get quantity, which is same as 50. We're going to add the order as we did before to the order table, so that you'll actually see it in the execution system, or actually in the order the order interface, and then the execution system is going to be invoked when we hit application send. It'll send it, and then we'll get the immediate execution. So we'll go ahead and run this part of the code. And what you can see is we now have a new MathWorks order for 50, and that it was executed and filled at 12.3. So that's how you can do a buy order. Now, in the previous set, I didn't tell anything. The default one is a buy order at the market. So if you wanted to actually set a new one, set a new object, create the object, do the same stuff, but this time you want to set the order side to sell. So there's a method on the order side object that it wants to take as an input. You set that, you tell it it's a sell parameter, and then set that for the side. And then you can send the sell order. You can see that that was executed, MathWorks 50 sell, buy and sell, and then you can see that it was actually shown up here as well. So it was executed through the system. So you can also use the same method for setting sides to set a variety of different other parameters, or set a limit order, for example. I'm not going to get into detail here, because this is just meant to kind of show you how you can actually use MATLAB and directly call Java components and use them as part of your application within MATLAB. So the last step is we want to go ahead and shut this down. So we'll tell initiator to stop, and that'll stop the connection between them. Now you can see disconnecting, received logout request. Now if I hit it, it's been logged out. So we'll go ahead and shut this down. Okay, so what we're going to do now is we're actually going to set up the trading system, and I'm going to show you a variety of the different components that are in there. So everything is within the trading system. And what we want to do now is actually go ahead and run the trading algorithm that I showed you before. So let me go ahead and open that, and I'll walk you through what it does real quick, and then I'll go ahead and start it and we can look at it running. First, we're going to create a messaging queue. You can now see that I have a system messaging queue class.net component. You can see some of the information that's contained in here. So you can actually browse through a .NET assembly within the variable editor. I'm not going to get into much detail on that one. Next step is we're going to have the system start up the executor. So we've got the executor here. It's waiting for a port. This is a server sitting off on our computer listening. And this one, of course, has the quick fix matching engine, which they implemented as a really simple one, which is going to fill all orders, and it's going to do them at a constant price of, I think, $12. So we'll be using that to demonstrate the fix's ability to send orders out and receive confirmations back, if you will. The next one is we're going to start Bonsai. So this is our application. One thing you'll note, that when it starts up, you get an interface here. It's went ahead and connected to the interface. So now I have all these different protocols available for me for the fix interface. Just a real quick example again. We'll go ahead and submit an order. Market order for the TMW at 25. You can see that it was added to the table, and also it was executed at the price of 12.3. So if we go back and look here, you can see information about it executing an order there. So we'll do that, but one other thing to notice, since I started all the Java components within MATLAB, this is now part of the MATLAB process. So if I kill MATLAB, the executor system will come down too. The next step is we're going to use the real-time, or we're going to use the tick history replay engine or the Reuters replay engine. This is the engine path and the config file where they're located, which is going to tell it to replay Brent crude data. And then this command is going to go ahead and execute that system. So we'll go ahead and start that. You can see it's sitting here listening for a connection. So now my trading system is all set up and ready to run. It's not going to do anything other than reflect the heartbeats every now and then of the fixed interface between Bonsai and Executor. And then my algorithm, which is actually under the trading system, has not yet been told to execute. So let me go ahead and arrange some of these windows. Do I have Excel? So maybe the Excel did not open, so let me go ahead and run that. So we got the Excel window open as well. So let me go ahead and start the playback, and then we'll dive into some of these components really quickly. So now it's going to connect. What we'll see, as before, we got our execution venue. The tick history replay is now playing. The fixed matching engine is over here. I'm going to put this one in front, and our order history monitoring Excel is here. Let's go back, detach this, so you can watch the timing. And the last thing is to bring up our execution system. So you can see the one I had, this is still ability to interact with it and send things. So you can see I can do submit. I can even change the protocol. And you can see the executions generated here. Now shortly once the system begins executing, you're going to see it. But let me talk about the components of the system. So I have this trading system function. So if we go in and look at trading system, what is it doing? Well, now you can see the plot is occurring. It should be starting to send and receive orders. What we have is basically the logic behind the trading system. A lot of this is setting up monitoring the security data. It's pulling in the security data, and then it's going to actually start generating a trading signal once the length of the security data is beyond this production parameters M. So once we're beyond the initial burn-in rate, then it triggers this part of the code, which you're seeing being executed here. So we can see we have basically two components: a generate trade signal. Now this is calculating the three different moving averages, combining them to signal using our parameters that we best fit from the earlier demonstration to create a trading signal, and then it's creating the plot trades. So if I go ahead and comment out this section, save it, you can see that the plot trades no longer is updating. So I'm actually able to update my code in real time as it works. Go ahead and save it, and now we've restarted. So if we go back one to the trading system, the other one is once we get an order, what do we want to do? We want to send an order out. So if we open that up, what you can see is we have different components. So we're getting the handle to the messaging bus. We have some logic parameters that says to use Xtrader or not, or to use the Bonsai interface or not. It goes through a signal with a switch statement that changes the trade state. So basically what I want to do is buy and sell based upon my current holding. So if I'm holding something, I mean, if I'm, for example, if it says to buy and I'm already bought, it's going to do none. And the same thing is, you know, if it's short, then I'm going to switch it. So this was changing the logic. It sends the update to the messaging bus, which you're seeing in the Excel interface, changing the state of the trade so that we can remember it next time this function is called. And then if Xtrader or Bonsai is implemented, it's going to send the order through them. Similarly for the other trade state when it's long. So that's the send order. It's using a persistent variable of trade state, the only thing that's persistent here. If we go back here, security data is persistent from call to call. The last thing was send order out. If we go back here though, we can really quickly look at the functions that are available in send order to Xtrader. So what this does is if Xtrader is empty, so if there's no connection available, it's going to create one, connect to the default instrument that we're trading on, and then if I close this section, then it's going to basically change the order profile to buy or sell and submit the limit orders that we saw earlier. And then of course it's only going to submit it if the server is up and running. Now similarly, let's go back and take a look at the send quick fix signal. If we look here, it's basically starting Bonsai as a global application so we can keep it in memory using the commands before. When it goes down here, if Bonsai is empty, so if it's not been previously declared, what we're going to do is create that application. This is essentially just telling it to pass with the Java and initiate everything under Bonsai. And then it's going to pause 5 seconds while we wait for Bonsai to get up and loaded. And then it's going to create an order object, and then every time the order table, it's going to create a new order object every time that you want to submit an object, basically, and that's what's being sent to the system. So essentially, that is the trading application. You can see it working here where it's sending signals. We're getting a variety of buy-sell signals sent to our execution system. You can see the logging being done within the messaging bus. And of course, if we go back to XTrader and look at our positions, you can see all the different buy-sell limit orders that are being added as the trading signal goes through there. Just go ahead and show the plot real quick. Every time we get a long or a short, you should see one of the new ones listed. So once this goes positive, there's another one. So in a nutshell, that's showing the whole system working and interacting with a variety of components. So just to summarize, we're actually executing orders through a simulator through XTrader. We're also executing orders simultaneously through a quick fix simulation engine. That was once again through the quick fix Java open source project. And we're also storing things through a messaging bus. So it's showing you a variety of different ways to connect to MATLAB and do a variety of different things. So if we close that, dock this, you can see how fast the system is executing, given that it's sending signals to a variety of different things and listening to events and being triggered. Roughly, 6/100ths of a second for this simple trading strategy that we're doing. So let me go ahead and stop this by going back to the trade simulator, and then we're going to go back to PowerPoints. So hopefully throughout that presentation you saw a variety of ways of addressing the challenges that you may have, and particularly the challenges we laid out initially, which were requirements for the trader. If you remember, commodities trader developing this with sophisticated analytics, scalable speed, and is quick to develop and deploy. We showed the solutions to that through MATLAB. The graphics environment toolboxes allow you to extend things. We didn't talk a lot about them, but there's a variety of ways to extend the base capabilities of MATLAB in products we call toolboxes. They're very flexible and customizable. The system I showed you was completely built from scratch within MATLAB and used different components from Java and .NET or the XTrader interface. You saw some parallel computing solutions, and then you also saw how easy it was to kind of develop the system, and then you can deploy it. And now what I want to do is really talk about deployment. So we did it from, the whole environment was run from the MATLAB environment. Let's say you wanted to give that trading app to someone who doesn't have MATLAB. The slide here illustrates how you can do that. So essentially there's MATLAB in all your toolboxes. You can build standalone apps and give them to other MATLAB users, showing the target down on the bottom. But if you wanted to give it to someone else, you could actually use what's called the MATLAB compiler and build standalone executables or libraries for other environments. And then if you wanted to build specific applications for Excel add-in without having to write any Visual Basic code, there's the Excel builder. There's a Java builder if you're targeting Java environments, and a .NET builder if you're targeting .NET environments. So what this allows you to do is give away all that stuff that was built in MATLAB to end user royalty-free. And just give you kind of an illustration of how that could potentially work. There are those in your quantitative organization who may be developing financial algorithms or trading systems. They want to deploy them to end users, which could be desktop systems, databases, analytic web applications, or to other environments. And then, of course, you have the consumers who are traders, portfolio managers, business analysts, as an example, who will be consuming those applications. So what we showed today was a trading application, but you're not limited to trading at all. You can develop a variety of different applications. And the last thing I want to leave you with is thinking about how you can embed the entire MATLAB algorithm or the components into other business systems where you don't need to have a license of MATLAB to be actually running these things. Two common scenarios come up are, like, for example, a business application server that might have a web front end. You can embed a variety of different MATLAB components that can run alongside or even within the same server as the business application. And similarly, you can call MATLAB from databases as a stored procedure or as a custom Java or .NET call, depending upon the database. So you can actually trigger calculations based upon events being entered into a database. And kind of the last thing to leave you with was just an illustration of how you can use all these different components, like we did in the trading application. You can hook them into an enterprise messaging bus, or maybe just a backplane you have of your system. Whatever the system you're using, you can integrate MATLAB or even MATLAB.NET analytics through a variety of different components, and even use the parallel computing capabilities running off those .NET analytics. So it just wants you to stimulate your thinking on how you can use MATLAB within the environment. So we're not necessarily articulating any one way to build a trading system. What I'm just trying to give you is a feel for that you can build the trading system that you want based upon a variety of different approaches, whether it's messaging buses, direct interfaces with Java, running it from MATLAB, or running it from another environment. You can expose the capabilities of MATLAB for the needs that best satisfy your trading situations. Thank you.